Hi, and welcome to a new chapter, a new topic. In this chapter, chapter 2, we're going to be talking about simultaneous equations and quadratics. And the first thing that we need to review in this video is how do we solve simultaneous equations? What are they? We already know different ways of solving them. We've solved them by elimination, substitution, and graphing. And that's what we just want to review and make sure that that's clear. You can always come back to this video in the future if you want to review these ideas more fully. So our aim is that we can remember different ways that we've learned to solve simultaneous equations. Some of these we learned last year, some we had learned already before that. So simultaneous equations is where you have two different equations, two different relationships that both have an x and y in them. And we know that the x and y in both of these equations are the same x and the same y. So we can eliminate, which is a technique to solve the equations by removing either the x or the y, one of the variables. We can substitute, which means I put x in place of, I put something in place of x, or I put something in place of y, so that there's something else being used there. Or we can solve them graphically. So that's how we're going to go through, and we're going to first talk about elimination, substitution, and then graphic solutions. So elimination, if you get eliminated, it means that something is taken away. And so in this case, this technique is that you want to get rid of x or y. So how do we do that? If we just have one equation, you can't get rid of x or y. And you can't solve it if you have two things that are unknown. But as soon as we have two equations, then we can use the two equations to eliminate one variable. So here, if I had these two equations, I could combine them to form a new equation with only one variable. So this is called eliminating. How we do this depends on the coefficients. The coefficient is that number that's multiplied with the x or the y. And remember, if there's nothing, it's assumed to be 1. In this case, if one of the variables has the same coefficient, then we don't need to modify either of the equations. So here you can see that y in both equations has the same variable. It's the variable 1. So since those coefficients are the same, since the coefficients are the same, then we can subtract them and it will eliminate the y's. So if I take first equation and subtract the second equation, I will get 0 y's because I had one y and I subtract another y. I will get 2 x's and I will get 4 on the right hand side there. I can then use those truths, 2x is equal to 4, to find out what x is. And then with x, we can go ahead and solve for y using either equation. So why can we do this? It's important to know the logic behind what we do in math. Why can I subtract the whole equation from the second, first from the second, or second from the first? Is because of the principle that if I do the same thing to both sides of an equation, it's fine. And we've maintained that equality because we've subtracted the same amount from both sides. How do we know it's the same amount? Because it was equal to itself. 2x plus y was equal to 12. So if we've subtracted one from the left side, one from the right side, we've subtracted the same thing. How about these equations? What will happen if we subtract these ones? Here you can see we have the same coefficient, 7, on both of these equations. So if we subtract them, we're going to end up eliminating the x terms. And that's fine. You can eliminate either of the variables. Here we would end up getting 5y is equal to 25. Now be careful when you subtract there. You have positive 3 minus a minus 2. So you get 5, positive 5. That leads to y equals 5. And then you can solve for x using either equation. Here is using the second equation, solving for x, and x is equal to 2. Look at these simultaneous equations. What do you notice about the coefficients of the variables here? You might say, oh, the b's are the same. Well, they're not exactly the same. Look at them. They have the same number, but they're opposite signs. But they're what's called a zero pair, which means that if I add them, I will eliminate one. So I add these two equations, I get 7a is equal to 35, and my b's have disappeared. I have 0 b's left. And then we can find out what a is equal to, and again, we've maintained equality. Why can we do this? Because we've added the same amount to both sides. Then you can find b using either equation. Look at the pairs of simultaneous equations here on the left-hand side and the methods on the right-hand side. This is a matching exercise. You're going to need to pause the video and think, for A, how would I eliminate something? Or which of the 4 statements on the right-hand side does it match with? And for B, which one does it match with? So pause the video, and when you've tried to match them all, then start the video again. Okay, hopefully you've tried. Maybe you copied this into your notebook, I hope so, or else you have your answers anyway. For A, if we subtract, we will eliminate the r's. For B, if we add, we will eliminate the t's, because they're a zero pair, see that? For C, neither adding nor subtracting will actually eliminate either variable. And for D, if you add, you would eliminate the r's. Now you could have also, for D, said if you subtract, you will eliminate the t. That wasn't an option anywhere, but that would also be true. So what do we do with ones like C, letter C, when we don't have the same variable coefficient? If the coefficient is the same, isn't the same, or isn't a zero pair, how do we eliminate one? Do you remember? Maybe you could share your ideas. Okay, welcome back. Hopefully, you remember that if there aren't any coefficients the same, we can modify one equation or the other. Now here's a different set of simultaneous equations where you don't have the coefficient the same. So there's some rearranging needed, but there's also a step of multiplying. We can multiply by something for one of the equations, or both of the equations if need be. In this case, we can multiply by 2. We can double equation number 1, and then it will end up having 4y's. We will rearrange it, and then we'll solve it by elimination. So if you multiply equation 1 by 2, you will end up getting 4y plus 6x is equal to 0. So then I'm able to subtract. Then I end up getting, mind the negatives again, 6 minus a minus 5 gives me 11x, which is equal to 0 minus a minus 22, which makes it positive 22, so x is 2. Once we have an x value, we substitute that back into either equation and come up with our y value, as shown. So this x and this y we have found by elimination. We had to modify one of the equations. And sometimes you have to do that in this method. So if we have 2 equations we've learned so far, linked by the same variables, we can add or subtract them to come up with a third relationship. And then if needed, we multiply one equation or the other by a constant to have 2 variables with the same coefficient, and then you can solve for the remaining variable. So that's elimination. Substitution. What was substitution again? Substitution means to put something in place of another. So substitution can be used to replace variables with something else. What we do is we look for a place where that variable can be the subject of the equation. Then we substitute that into the other equation. Now in this case, both of these equations have x as the subject of the equation. X is this and x is this. Because x is equal to both of these things, we can substitute 5y plus 2 into that first equation. That's x. So I can say, well, then 5y plus 2 must equal 3y plus 6. You see that? Now we can solve it, says Isha, like any other linear equation. We find out what y is by rearranging. Once we found out y, then we can solve for x. You can use the same method if you have one variable that's the subject of one of the equations and not the other. For example, here, because I have y is equal to something, I can use that and I can put that in for y in the first equation. 4x minus 25 comes in place of the y in that first equation. Now you can manipulate it and you can solve it just like you do other linear equations, finding first what's x, and then if that's x, then you can find y. Remember, you can always go back and substitute the values of x and y into both equations to make sure you've done it correctly. If you have the time, that's always a good practice. Sometimes, now we've talked about two methods, elimination and substitution. And we know that sometimes you have to choose which one are you going to use. Usually try to pick the one that seems the most efficient for whatever these equations are. For example, if I had these two equations, there would be various ways I could solve them. I could solve them by making one of the variables a subject. We could rearrange the top equation and make a the subject. I would have negative b, 3b plus 14. Or I could divide the bottom equation by 2 and make b the subject. You could also solve by elimination if you multiply the top equation by 10, made this 10a and 10a, and then you could rearrange and eliminate. So you're always making choices, but choose the one that works best for you. Just as a demonstration, let's do this second option, that we could divide the bottom equation by 2. If we did that, we make b the subject of the second equation. So we divide by 2, b is then equal to 5a minus 6. Now I substitute that into the first equation, and then I solve for a. If a is 2, then I can find out what b is by using either the first, second, or the third equation that I created by dividing. Then I can find out that b is 4. You can again try these values in any of the equations and they should work. Here's a sample of how you could check. Put the two values in and check that left-hand side equals right-hand side. And it does. So these are the solutions to this simultaneous equations. I have 3 here on the board, which I would like you to write down in your notebook and see if you can solve A, B, and C. Which method you pick is your choice, but see if you can come up with X and Y as practice. Okay, let's pause the video. Welcome back. Hopefully you've done all 3 of these now. I'm just going to show you one possible method. You may have done a different method. I did the first one by substitution, substituting in what y is equal to. You should come up with the same x and y even if you chose a different method. I did the second one by elimination. I decided to multiply the second equation by 2, and then I eliminated. You could definitely do it different ways, but you should come up with x is 2 and y is minus 2. Then you have the last one, and here the most efficient method is really personal preference. You could multiply both of them by a number, you could rearrange them. You should come up with the answer x is equal to minus 4 and y is equal to minus 5. Okay, let's review what we've learned so far. So elimination, substitution, we remember that we learned that you can solve simultaneous equations this way. And if you look at the features of the equation, it can help you pick which method to use. So we've done elimination, we've done substitution. Let's just remember how we talked about solving simultaneous equations graphically. To solve graphically, we plot both of these lines, if they're linear equations, and we identify the points of intersection. And that point of intersection is the solution. Okay, so first we're going to talk about doing it without technology, and then we're going to practice doing it with some technology. If you are going to use a graphical method to solve a pair of simultaneous equations, basically what you're doing is you're taking two equations and you're graphing them. Remember when we graphed equations, we made a table of values and then we plotted the points. So that top equation would look like the blue line on your screen. If we plotted the points, made a table of values again for the second equation, remember a table of values is, I think, okay, if x is 0, then put it into the equation, y would be 3. If x is 1, y would be 3 minus 2, which is 1. Okay, so we fill those in, then we plot the graph, plot the points, connect the points, and we've graphed both lines. What do we do after that? Well, we look for the point of intersection. That is the solution to the simultaneous equations. That point of intersection here is, can you see it? Shows us where they meet. So our solution is x is 1, y is 1. And that is the only point which is true for both equations. If you were going to go ahead and try these values, you would see that they work for both equations. They are true when you put in x is 1, y is 1. If you try any other point, like say we said, well, I'm just going to try one point on the blue line. It works for one of the equations, the blue line, but it doesn't work for the other line. So this other point doesn't satisfy both. Okay, now it's your turn. You look at these two lines and you choose which answer is correct, which solution satisfies these simultaneous equations if they're graphed here correctly. Okay, pause the video, come up with your answer. All right, hopefully you came up with the same answer that I did. It's not the first one because that only satisfies one equation. It's not that second one either. That only satisfies the black line. It is C because this is the point of intersection. It's not D. How about this one? Pause the video. What do you think is the answer here? Okay, hopefully you're getting to see quicker that I just look for that point of intersection. And that would be x is minus 1, y is 4. It satisfies both of the equations. Now, I hope that you have access to some tablets, and we want to try the rest of this video having some tablets. Maybe one between two would be fine. We're going to just try graphing a few things. Now, we've done this before, and graphing technology can just help us to see things quicker and easier. Open up a web browser if you haven't already done so and go to desmos.com. When you're ready, then press the graphing calculator button and carry on till you get a graph looking like this. Now punch in these two pairs of simultaneous equations. You'll need to pause the video until you've done it. They will show up on the left-hand side there. If you punch in these lines correctly, you should end up getting two lines on your tablet. If you click on the point of intersection, it will show you what the value of the point of intersection is. Okay, now delete those ones and try these two equations. You should still be using desmos.com to do this. Okay, and pause the video until you've punched these in. It depends on how, are you ready? Depends on how you have your scale. You might need to scroll in or out because the point of intersection is way off maybe a normal graph, but they do still intersect at the point x is 64 and y is minus 22. How about this pair of simultaneous equations? Punch these in. How many solutions do you find? They don't have any solutions. They don't actually cross each other. What kind of lines are they? They're parallel lines, aren't they? If lines are parallel, then there is no place of intersection and there is no solution. You could have, there's no place where these will have the same x value and y value. Punch in these equations. How many solutions would you find? Maybe you can write a sentence also describing why you only find, how many solutions you find. Okay, once you've started the video again, you should have gotten a graph that looks something like this. How many solutions? There are no solutions because, and the reason being, if you were justifying your answer, both lines have the same gradient, the lines are parallel, they won't intersect, therefore there's no solution. How about these two? Okay, pause the video, punch in these equations and see how many points of intersection they have. You should get a graph that looks something like this. It has one solution. You can say what that solution is. You might have said they have one intersection and one solution that solves both equations. How about this one? How many solutions? This is another interesting case. These lines are actually on top of each other. So what we say is that they have an infinite number of solutions because any xy pair from one line will work for the xy pair from the other line. They lie on top of each other. So they don't just have one place of intersection, they have infinite numbers of points of intersection. All right, so we have remembered that we have in the past already learned how to solve two simultaneous equations by elimination, substitution, or graphing. We can graph the lines on paper, or we can graph them using graphing technology. That's it for this lesson. We'll review again another concept in part 2. Have a good day.